secant to the power of 4x. Now, can you work out a strategy to do this? You see, if you have tan to the power of something and secant squared x, if you have secant squared x dx available, then you can actually do any integral of the form. Let me show you that. If I have a tan to the power of n secant squared x. Now, tan to the power of nx. This n can be any number. Tan to the power of nx secant squared x dx. Must be a dx also here. You can actually do this by substituting tan x equal to u. Tan x equal to u, secant squared x dx will be your du. Now, can you think of reducing this to this form? What method would you adopt to reduce this to that form? Think about it. I'm going to give you a couple of seconds to think about it. And see whether you really got it. Well, if you got it, that is good. If you didn't get it, don't worry, we will reach there. Well, what you need to do is secant to the power of 4x, write it as secant squared x times secant squared x. And the last secant squared x, we leave it there for taking care of du. And the first secant squared x we need to change in terms of tan x. How do you change secant squared x in terms of tan x? Because 1 plus tan squared x equal to secant squared x. So the secant squared x can be changed into tan squared x as 1 plus tan squared x. Alright, let's try doing that. So we have, first of all, this is a differential equation. So y prime, write it as dy by dx. dy by dx equal to square root tan x secant to the power of 4x. Our aim is to solve y as a function of x, is that right? So first of all, multiply both sides by dx. That will give you dy equal to square root tan x secant to the power of 4x dx. And now integrate both sides. Integral dy will give you y, and y will be therefore integral of the right hand side. So y integral dy equal to integral square root tan x secant to the power of 4x dx. And we have therefore y equal to this integral. And how do you do this integral? We just talked about it. Okay, and look at the way we write it. The way I just talked to you earlier. Y equal to integral square root tan x secant to the power of 4x is written as secant squared x times secant squared x. And I colored one red and left the other one the same color. Why? Because the last secant squared x dx is going to take care of our du. And this secant squared x need to change in terms of tan x. Right. So that will be secant squared x is now written as 1 plus tan squared x. Alright, remember, square root of tan x, square root of a quantity is raised to the power of 1/2. So when you distribute it, I can write it as quantity tan x raised to the power of 1/2 plus square root multiplied by tan squared x. You see, it will be quantity tan x raised to the power of 1/2 times tan squared x. That will be tan x raised to the power of 1/2 plus 2. What is 1/2 plus 2? It's 5/2. So this will be, when you expand it, it will be tan x, quantity tan x raised to the power of 1/2 plus quantity tan x raised to the power of 5/2. I hope you can keep these things in your mind. It's very important in mathematics to talk to yourself when you do problems. All right, let's now do that. Or, to make it simpler, let's do a substitution, and then we will distribute. All right, substitute tan x equal to u now. Tan x equal to u. When tan x equal to u, take the differential. Secant squared x dx equal to du. So when tan x becomes u, secant squared dx becomes du. You have square root u times 1 plus u squared du. It is much simpler to distribute now. Is that right? Square root u is u to the power of 1/2. So when you distribute it, it will be u to the power of 1/2 plus square root u times u squared will be u to the power of 5/2. There you go. So y equal to integral u to the power of 1/2 plus u to the power of 5/2 du. All right, what's integral u to the power of 1/2 du? That will be u to the power of 1/2 plus 1 over 1/2 plus 1, which is u to the power of 3/2 over 3/2. And what is integral of u to the power of 5/2 du? It is u to the power of 5/2 plus 1 over 5/2 plus 1. And that will be u to the power of 7/2 over 7/2. So integral u to the power of 1/2 du is u to the power of 3/2 over 3/2 plus integral u to the power of 5/2 du is u to the power of 7/2 over 7/2. And you can see these two will go up. Is that right? So this is 2/3 u to the power of 3/2. And this is 2/7 u to the power of 7/2. What is our u? Or we can factor out a, look at that, the common denominator here is 21, and on the top you have a u to the power of 3/2 common. So we take 2u to the power of 3/2 divided by 21 out. Now what is left here? When you take 21 from the denominator, this will get multiplied by 7. So 2u to the power of 3/2 over 21 has come out, leaving a 7 here, plus. Now remember, 7/2 is 3/2 plus 2. Is that right? 3/2 plus 2 is 7/2. So from u to the power of 7/2, you take out a u to the power of 1/2. What is left is u to the power of 2. So what is left there is 3u to the power of 2. I hope you understand that. When 21 comes out as the common denominator, this will get multiplied by 7 and this will get multiplied by 3. So 2u to the power of 3/2 over 21. What is left here is 7 plus what is left there is 3u squared plus c. And now we have u to the power of 3/2 can be written as u times square root of u. Just a simple step which is not probably necessary, but because the original quantity is under square root, it makes sense to do that. Alright, now replace your u. Our u equal to tan x. So what's our result? Y equal to 2 tan x square root of tan x, 2u square root of u, 2 tan x square root of tan x divided by 21 times 7 plus 3 tan squared x plus c. And that is the solution of this differential equation. All right.